who is Simplexity? The company I am from. We are a little small company in Zurich in Switzerland. And what we do is actually consulting and training 2110 and NMOS. And what we really care about is like, what do we really buy? What does it help? And what can we buy to help us in the real world? So this presentation is basically about, you know, what you could ask for as an end user and as a manufacturer, where you should set your priorities in implementing stuff. So we got a great overview from Spencer, what's there in NMOS, but so I'm gonna narrow it all down and go through it step by step, based on an example where I just wanna unpack an equipment and plug it in and see how much and what the steps are to make it operational. So, generally, what are the goals of NMOS? Again, slightly from a different angle. NMOS wants dynamic setups. Everyone wants it, but how real is it today, in broadcast particularly? But that's the goal, and we want to be independent of manufacturers. No driver for specific devices. That's the idea as well. And we want to use modern web-based technologies to leverage from the IT. Those are the main goals really NMOS has set. So why? Why should we want to do that? Ultimately, it's about cost reduction. And I believe the reduction of cost has a lot to do with operational costs you're going to have afterwards. If you want to train everyone to every detail, it's going to cost you a lot. In order to make it more automatic, it's going to save cost. So the infrastructure you're buying actually has to allow that flexibility. What you do with it, it's obviously your responsibility, but if the infrastructure is not flexible, you can't change your workflows. So I think everyone's talking 2110 and whatever, and yes, sure it's there, but I believe it's not there as it should be today. It's much too static. It doesn't really do what, you know, in many cases, what you initially expected from it. Now, plugging it in, getting audio and video flowing, moving it somewhere else and do it the same thing there. A lot of installations are even nailed down to interfaces, doing a specific signal. And you can't just move over there and plug it in there and go on. Doesn't work, many cases. So basically, it's a chicken and egg thing. If you accept what's there and you don't go to the vendors and say, we want this to be different, they will not change because they think that's what you want. So this presentation is about a different angle on that one. So what are the steps to take a device into operation? I want to go through 5 steps, basically. One is a setup step. Second one is the registration discovery. You recognize that from Spencer's presentation. Configure the streams. And no, they don't have to be static. They can be changing. They should be. And then connect the senders and receivers. And finally, monitor. Because whereas you had some XY matrices before, now you have a distributed system across your whole facility or even between facilities. This is not as static and behaving as you wanted it to be. You have to know what's going on. So the monitoring is very, very important. So these are some numbers. I don't go into the numbers here. I just don't care about them. But there is all the numbers. You can find these specifications. So let's go on a stage and identify the roles in this stage when I want to now start doing a play. I have a control software, I have some AV devices, and I have a number of servers in my infrastructure. So in the next slides, I basically want to show how this can be plug and play. So I'm going to basically use these 3 different players, the control software, the AV devices, and let's call it IT infrastructure of some servers, and see what they're actually doing when you start plugging in a device. So learn the stage, the setup stage, right? The setup step of everything. What's happening there? The AV device, in my view, would go in there and ask for an IP address. You don't have to do that. That's why DHCP is there for. So it asks the DHCP server for configuration. And that has been invented something like 20 years ago. So the DHCP server answers with some of the information. It can do actually quite a lot more than just setting up IP addresses, but that's what we are going into now here. Then the next one is the AV device. As we heard, there is a specification for some global parameters of the setup, like a PTP domain. I don't want to set up my PTP domain. I want the system to learn it. So the next step is that guy asks the DNS server, the name server in the IT, hey, what's the address of my system API? Like where I can ask all the stuff which is valid in my installation. And then finally, it basically goes to that place and says, hey, what's the PTP domain in this setup? I'm just simplifying here. It's asking more stuff, but that's what's counting for you guys. So there is a spec which you can actually, with using this, you can automate setting up the PTP stuff. Then as the next one, it asks for the control software as well as the AV device. They say, where's my registry? The same thing. You shouldn't have to type in an IP address of your registration server. It's there in the specs. You can just ask a name, a reserved name, and it asks for that name, and it will be resolved automatically. So that's the basic setup. Then the next one is basically discovery registration. The AV devices basically go to that registry, which they have now identified, and put in their senders, receivers, and a lot of more stuff, including their capabilities. And that ISO4 registry, the infrastructure, hosts that information. It stores it there. Same thing now, the control software says, who is there? I'm going to query and ask for all of this. So he knows who is there. And finally, it also says, hey, please send me updates if anything changes. So that guy wants to know what the current subscriptions and whatever is. So that's all done in the registration and discovery. Next one is configuration. Get to know your part. So I mean configuration of your senders and receivers. Here again, control software can query the capabilities of senders and receivers. What can you do? Can you do 8 channels? Can you do 2 channels? Can you do HD? Can you do 4K? It can query that, and actually the infrastructure does provide that information to the setup, to the control software. And as a next step, the software then basically tells the sender how many channels to do. It's all written there in the spec IS11, which already mentioned by Spencer. Then you have to set up the internal matrices of the devices. Again, there is a spec for that. And finally, don't forget, even ISO 5, which has been there for years, allows every sender to get a flexible multicast address. No, you don't have to set up the multicast addresses statically for your infrastructure. You can actually have your control software doing that. And it's already working widely. So it's just that you have to ask the control software guys, please implement multicast management. So, and finally we connect. That's what we know already. The control software basically copy-pastes the transport file to a receiver. But it's important to know the receivers then start to subscribe to the stream. There's nothing sent to a specific place. The guy says, hey, I want that guy. I want those packets. And then the network sends it to that receiver. So, and then again, it does update the registry and say, I am connected to that sender. In the registry, you have a reference for that. So the control software then can show, there has been a connection between these senders and receivers. And by the way, if you have multiple UIs, they will synchronize automatically because they all reference to the registry. You can have multiple UIs running in parallel and they will subscribe automatically to the updates. So the question is now, did that really happen? Did it really work? And the magic is, you know, are the streams flowing? Are the packets flowing? Do I just see an updated patch point on my UI, or is it really happening? And that's where I think after doing all this magic stuff, what we need, the next big step is a monitoring step. And that's why it's actually brand new. It's released now. It's called BCP08. And in the monitoring side, that actually allows you where the monitoring now, standardized monitoring now allows to basically check what's going on really. Down to packet level, down to PTP level, and so on and so on. How that works is this. So there is this new spec called BCP008, and that's what you have to, as an end user, go to the manufacturers and say, do you do BCP08? It's going to save a lot of your time and maybe your life. Not your life, but let's say your production, right? So basically, the control software in this case can query statuses of senders. That's you know who is there which supports BCP08, and then it says, hey, tell me if something changes. So the control guy, which becomes the monitoring part, right, says who can do BCP08? The guys who can. I want to subscribe to any state changes you do, and then it basically it can indicate that red, green, whatever state to the user interface. I'll tell you in more details how that works. And yes, you can query then more details, whatever. But the main thing is, you know, do you have everything you need? Are you okay? That's a very simplistic monitoring approach. And that's standardized now. So let me introduce you to this BCP08 very quickly, because I think it's so new that a lot of people don't know about it. Has been missing in your presentation as well. So the BCP08, the traffic light approach, the monitoring approach in a standardized way, basically says every sender and every receiver provides you a number of traffic lights. And the colors are kind of specified. It's green if everything's great. It's yellow if things are still okay, but there's some stuff happening, like you lost a network B, but you still have A, that kind of stuff. And obviously red if something is really unhealthy and there's a real problem. Everyone understands traffic lights. So inside, what are actually the domains, as we call it, the reporting domains? Every sender and every receiver is feeding back to the world, to the control system and monitoring system. It's actually the overall state, which says I'm completely okay, whatever. And there are 4 what we call domain statuses. 4 traffic lights in every sender and 4 traffic lights in every receiver. Basically, 2 of them are checking connectivity. They say, I got all the links I expect, up and down or whatever, and the second one says, I got all the packets I need. Or maybe they are too late, whatever. That's another traffic light. That synchronization traffic light says, I got all the synchronization I need. And we keep it very open. If you only expect synchronization on network A, you are green, and if it's gone, it's red. But if you expect synchronization on A and B, then that would actually use the yellow state in the middle. And finally, you check whether you can decode the stream on the receiver, or a sender says, I got something to send. For instance, if there's no SDI connected, there's nothing to send there. So it's also a capability to monitor that. Now, all these traffic lights try to channel what the manufacturers most likely already have in their products. We don't force them to implement stuff they don't have, but we force them to report it in this way. So you guys get it back as a traffic light. Now, the overall state, there's a spec saying it always has to take the worst state of all the members. And that guy you want to see on the UI straight, because that's what's showing you everything's cool. So I want to demo that quickly. That's why I use my laptop. I'm not sure whether we have, can I just try to hold in my hand? Maybe it works. I have here reload. Hopefully that works. Yeah, it does. So there's a UI, a very simple UI. Some senders and a receiver. And the top ones support BCP08, the monitoring. You can already tell there's a green light on the sender side. If I connect the sender to a receiver, let me do that. You see a green light coming up on the receiver side as well. All cool. Now, that's a demo, right? But so I can fake some problems here. Let me take down a NIC1 of a redundant device, right? If I do that, you immediately see that the traffic light turns orange. And it says there's something not quite right there. And as an operator, I see it's yellow, it's not red, right? Because if it's red, then I really have a problem. So if my UI allows the user to check the details, I can go in there and I see the 4 domains in there. in this case, because the NIC1 is down, that influences packet loss and it influences synchronization as well. By the way, the texts here are twisted in the demo here. So basically, link 1 is down and there's a packet loss, of course, and I have also no sync on NIC 1. And I think that's already very, very intuitively clear what's going on. The packets are still okay, the stream decoding. So basically, on the sender side, it looks very similar. Links and synchronization is exactly the same. On that side, where we detect packet losses on the receiver side, the sender may report transmission errors. So you see, this is very generic. It's not bound to 2110. You could have SRT or whatever, where there's transmission errors. So that would be the traffic light for that. And on the fourth one, where we decode the stream on the receiver side, the sender could say, I don't have anything to transmit. For instance, there's no signal on SDI in 3. So that's a red state, right? Although it has nothing to do with my IP, but in practice, it's as much of a problem as it is to have a network issue, right? So in this case, the overall state would go red and say, no signal on SDI in 3. It basically takes the worst of all of them. So basically, that's what BCP08 is doing. And that's brand new, but it is as simplified as possible, both from the vendors and actually also from a UI perspective. So that overall state can then be mapped to the UI straight. And yes, by the way, there's a little counters, because if you forget to check and it's green, like it will be right now, there's a little one saying there was an incident before. So there's a little counter. It's not a logging, right? But it just says there was something happening. So logging is still the part of control systems and monitoring systems. But the end devices, they do what they do best in a very, very simple way. So what we do is basically we move some of the logic and intelligence into the edge devices, so they don't report stuff which you are not interested in. For instance, if the sender is disabled, the receiver is disabled, not connected, it shouldn't report packet loss, right? It doesn't, because that's as it's specified. So we put in some very simple practical rules for that in order to make your lives easier. Okay, I guess I want to leave you with some documents and links, which is maybe important and interesting to read. And now we are probably both open for questions. Thank you.